J.I. Case Company Service Education Department presents the RPS-34 power shift transmission and how it works. The RPS-34 power shift transmission is available as a drive option on the 770, 870, 970, 1070, and 1090 Agra King tractors, and is located between the engine flywheel and the mechanical four-speed section of the transmission case. The power shift transmission assembly consists of an input shaft, which also drives the PTO at engine speed, a compound planetary which accepts the input rotation and causes a reduction in output speed for a torque increase in the low and intermediate speed selections. Also, output shaft that transmits power from either the compound planetary or directly from the engine, depending on speed selections made. And 4 hydraulically engaged, spring-released clutches. The input shaft is spline coupled to and driven by the spring-cushioned hub of the torque limiter plate. The output shaft speed is determined by the engaged clutch combinations, which controls the input to output speed ratios through the planetary assembly. The selector lever on the operator's console is used to select the engaged clutch combinations for each speed selection. A combination of 2 clutches must be engaged for a completed drivetrain. When the power shift selector lever is in low, clutches number 1 and 2 are engaged. Power is transmitted from the input shaft and primary sun gear through the small diameter planetary gear and into the large diameter planetary gear. The reaction sun gear is held stationary by the engaged C1 clutch, and rotation of the large diameter planetary gear causes the planetary carrier and outer drum to be rotated in the same direction as the input shaft, but at reduced speeds. The engaged C2 clutch locks the rotating planetary carrier to the output shaft, which transmits the available power out through the output gear. The outer drum is also rotating, but is not driving the output shaft because the C3 clutch is released. When the power shift lever is in intermediate or second, clutches number 1 and 3 are engaged. The power is transmitted from the input shaft and primary sun gear through the small diameter planetary gear and into the large diameter planetary gear. The reaction sun gear is held stationary by the engaged C1 clutch, and rotation of the large diameter planetary gear causes the planetary carrier and outer drum to be rotated in the same direction as the input shaft, but at reduced speeds. The engaged C3 clutch locks the rotating outer drum to the output shaft, which transmits the available power through the output gear. The planetary carrier is also rotating, but is not driving the output shaft because the C2 clutch is released. When the power shift lever is in high or third, clutches number 2 and 3 are engaged. Power is transmitted from the input shaft directly to the output shaft for a direct ratio power transfer. The engagement of the C3 clutch locks the outer drum to the output shaft, and the engaged C2 clutch locks the planetary carrier to the output shaft. Any rotation of the planetary gears is prevented. Locking the output shaft, outer drum, planetary carrier, planetary gears, primary sun gear, reaction sun gear, and input shaft into a single rotating mass. The released C1 and C4 clutches permit the outer drum and reaction sun gear to rotate at equal speeds for the direct speed transfer of power from the engine to the output gear. When the power shift is in reverse, clutches number 2 and 4 are engaged. Power is transmitted from the input shaft and primary sun gear through the small diameter planetary gear and into the large diameter planetary gear. The outer drum is held stationary by the engaged C4 clutch, and rotation of the large diameter planetary gear causes the planetary carrier to be rotated at the same speed as the input shaft, but in the opposite direction. The engaged C2 clutch transmits the planetary carrier rotation to the output shaft, which delivers the available power out through the output gear. The power shift transmission is neutralized by depressing the clutch pedal, which engages the C4 clutch. All other clutches are released. In neutral, power is available from the input shaft and primary sun gear. This rotation is transmitted through the small diameter planetary gear and into the large diameter planetary gear. The outer drum is held stationary by the engaged C4 clutch, and rotation of the large diameter planetary gear causes the planetary carrier to be rotated in the direction opposite the input shaft. The released C2 clutch prevents any power transfer to the output shaft. The outer drum is stationary, preventing any power transfer to the C3 clutch. As a result, no power is available to the output shaft. Some rotation of the output shaft could occur due to friction at the C2 clutch plates. The transmission hydraulic system is supplied with oil from the 16 GPM section of the rear-mounted tandem pump. All oil from this pump section is delivered to the flow divider and PTO control valve, where the flow is divided into two separate systems. The flow priority is directed out of the top of the valve body through the 10-micron filter and to the transmission control valve mounted on top of the transmission case. The hydraulic PTO clutch is also supplied with pressurized oil from the transmission supply circuit. All oil not required in the transmission circuit is directed to the remote control valve and then to the draft-o-matic control valve. The function of the flow divider valve may be shown more clearly by starting with a power-off illustration. The flow divider spool is positioned to the extreme left by spring pressure. The gallery supplying the transmission valve is open, and the gallery supplying the remote and draft-o-matic valves is closed. When the engine is started, oil is supplied through the open gallery to the transmission control valve, where it is directed into two clutches. There is more oil volume available from the pump than is required to keep the clutches engaged, and as a result, an immediate pressure rise is experienced in the transmission supply gallery. The pressure is sensed through a pressure transfer orifice against the end of the flow divider spool opposite the spring. The spool is moved to the right, reducing the flow to the transmission circuit and diverting the excess volume of oil into the now open remote and draft-o-matic circuit. The flow divider spring tension may be adjusted by removing or adding shims. The spring tension controls the pressure level at which the flow divider spool balances out, or the regulated pressure of the transmission supply gallery. So, the flow divider circuit spool is also the pressure regulator for the transmission clutch circuits and PTO clutch. If the transmission circuitry should develop an increase in leakage, causing a requirement for additional volume, a momentary pressure drop would occur in the transmission gallery and through the pressure transfer orifice. This pressure drop would permit the spring to push the flow divider spool to the left, opening the transmission circuit to increased flow. When the flow increase becomes sufficient to again cause a pressure rise in the transmission circuit, the flow divider spool will balance in a position supplying the transmission with the required volume of oil and maintaining the regulated pressure in that circuit. If the remote or draft-o-matic valve was actuated, a higher range pressure level would be developed back through the flow divider spool area. The sudden rise in pressure in this area would cause a flow increase into the transmission circuit. The excessive flow into the transmission supply gallery would cause a pressure rise, moving the flow divider spool to the right and restricting the flow available to the transmission circuit. As a result, the flow divider would have been repositioned to again allow only the flow required to maintain the transmission circuit at a pressure level of 180 to 200 psi. In the event that a pressure rise should occur in the transmission supply gallery faster than the flow divider spool could sense and react to regulate the pressure, the transmission circuit high pressure secondary relief valve would open. The pressure setting of this valve is approximately 250 psi. The relief action of this valve would normally occur in the instance of a cold oil start, and for this reason it is described as a cold oil relief valve. The PTO clutch spool is located in the flow divider and PTO valve body in a position to supply oil to the PTO clutch from the transmission supply gallery. When the spool is positioned as shown, the PTO clutch is spring released. Moving the spool into the valve body directs oil from the transmission supply gallery to the PTO clutch. The pressure level on the oil directed to clutch is below that in the transmission circuit due to the low relief value of the clutch modulation valve. As the spool is moved further into the valve body, the modulation valve spring tension increases and a corresponding clutch pressure increase occurs. When the spool is moved full stroke, the modulation valve spring pressure is high enough that there is no relief action at that point, and PTO clutch pressure regulation is accomplished by the flow divider valve spool. The material presented to you at this time has had the primary purpose of familiarizing you with how the power shift works mechanically and with the means of supplying the pressurized oil to make the unit hydraulically functional. Now, the heart of the RPS-34 power shift transmission, the transmission control valve, and its many functions will be explained. The selector spool is mechanically operated by actuating the power shift selector lever on the operator's console. The selector spool is used to supply pressurized oil to two clutch pilots in each of its detent positions. The clutch spool is also mechanically operated by depressing or releasing the clutch pedal and has the purpose of neutralizing the drivetrain with the pedal depressed. There are 4 clutch pilot valves, one for each clutch in the power shift transmission. The pilot valves are hydraulically opened, spring closed, and have the purpose of opening or closing clutch energizing circuits as determined by the selector spool position. The reverse lockout spool is hydraulically actuated, spring released, and has the purpose of preventing a shift into or out of reverse unless the clutch is depressed. When the spool is pressurized downward, a tang at the lower end of the spool projects into a slotted area of the selector spool. The slot allows free selector spool travel for selection of first, second, and third speeds, but prevents selector spool movement to reverse. When the lockout spool is depressurized and raised by spring force, the tang is retracted from the selector spool slot and the selector spool can be shifted to the reverse position. The action of the reverse lockout spool is controlled by the clutch spool position. There are 2 retard valves, one in the C2 clutch pilot circuit at the left and one in the C3 clutch pilot circuit at the right. The retard valves have the purpose of slowing down the release of the C2 and C3 clutches during shifting and are responsible for the smooth shifting characteristics of the transmission. The C2 shuttle valve permits pressurization of the C2 pilot valve from 2 different selector spool positions. The floating check ball is positioned against the seat opposite the incoming flow and causes the pressurized flow of oil to be directed to the C2 pilot valve. If the selector spool was moved to the opposite C2 supply position, the pressurized flow would enter the shuttle valve from the opposite side, positioning the ball against the seat port that had previously been open. The pressure regulator is located in the steering return to reservoir circuit and causes a back pressure condition in that circuit. The pressure level maintained by the pressure regulator is used to hydraulically actuate the reverse lockout spool. When the pressure in the reverse lockout circuit reaches the regulator setting, the regulator opens to pass all excess oil volume into the clutch lubrication circuit. There are 3 basic circuit divisions within the power shift valve. The circuitry indicated in red is the supply circuit and has the purpose of supplying pressurized oil to the clutches when the pilots are actuated. The circuitry indicated in orange is the pilot actuator circuit and has the purpose of directing pressurized oil from the supply circuit through the selector spool and to the selected pilot valves. The circuitry indicated in yellow is the reverse lockout and clutch lubrication circuit. Remembering the purpose of each of these circuits will permit a more thorough understanding of the control valve flows in each speed selection. When the selector lever is in low, the selector spool is positioned to engage the C1 and C2 clutches. Pressurized oil is directed from the selector spool into the C1 pilot circuit, which is routed through the reverse lockout spool lands. The C1 pilot is actuated, permitting pressurized oil from the supply gallery to pass through the pilot and into the C1 clutch. Pressurized oil is also directed from the selector spool into the C2 pilot circuit, which is routed through the C2 shuttle valve and the opened C2 retard valve check ball. The C2 pilot is actuated, permitting pressurized oil from the supply gallery to pass through the pilot and into the C2 clutch. The steering return oil enters the valve body and flows by the clutch spool to the pressure regulator. A pressure rise is experienced because of the regulator spring resistance, causing the reverse lockout spool to be pressurized. When the reverse lockout spool is pressurized, the spool tang is engaged with the slotted area of the selector spool, and the spool land position permits completion of the C1 pilot actuator circuit. When the pressure in the steering return circuit reaches the regulator setting, the regulator opens and dumps the excess volume into the clutch lubrication circuit. When the selector lever is in intermediate or second, the selector spool is positioned to engage the C1 and C3 clutches. Pressurized oil is directed from the selector spool into the C1 pilot circuit, which is routed through the reverse lockout spool lands. The C1 pilot is actuated, permitting pressurized oil from the supply gallery to pass through the pilot and into the C1 clutch. Pressurized oil is also directed from the selector spool into the C3 pilot circuit, which is routed through the open C3 retard valve check ball. The C3 pilot is actuated, permitting pressurized oil from the supply gallery to pass through the pilot and into the C3 clutch. The steering return, reverse lockout, and clutch lubrication circuits are functioning in the same manner described in the low drive illustration. When the selector lever is in high, the selector spool is positioned to engage the C2 and C3 clutches. Pressurized oil is directed into the C2 pilot circuit, which is routed through the C2 shuttle valve and the opened C2 retard check ball. The C2 pilot is actuated, permitting pressurized oil from the supply gallery to pass through the pilot and into the C2 clutch. Pressurized oil is also directed from the selector spool into the C3 pilot circuit, which is routed through the open C3 retard check ball. The C3 pilot is actuated, permitting pressurized oil from the supply gallery to pass through the pilot and into the C3 clutch. The steering return, reverse lockout, and clutch lubrication circuits are functioning the same as described earlier. When the selector lever is in reverse, the selector spool is positioned to engage the C2 and C4 clutches. Pressurized oil is directed from the selector spool into the C2 pilot circuit, which is routed through the C2 shuttle valve and the opened C2 retard check ball. The C2 pilot is actuated, permitting pressurized oil from the supply gallery to pass through the pilot and into the C2 clutch. Pressurized oil is also directed from the selector spool into the C4 pilot circuit, which is routed through the reverse lockout spool lands. The C4 pilot is actuated, permitting pressurized oil from the supply gallery to pass through the pilot and into the C4 clutch. The steering return, reverse lockout, and clutch lubrication circuits again remain the same. To obtain a neutralized drive condition in the power shift transmission, the clutch pedal must be depressed. The clutch spool is pulled out of the valve to a position opening 2, return to reservoir circuits. The steering return oil cannot be pressurized. The reverse lockout spool cannot be actuated, and the return spring releases the lockout spool. This action prevents any mechanical interference to the movement of the selector spool into or out of reverse and causes a change in the pilot actuator circuits. In this illustration, the selector spool is positioned for low drive, and the C1 and C2 pilots would normally be actuated. The reverse lockout spool position causes the C1 pilot circuit to be shut off and opens the C2 pilot circuit to reservoir. The reverse lockout spool position also permits pressurized oil from the right-hand end of the selector spool to pass to and actuate the C4 pilot. The actuated pilot permits pressurized oil from the supply gallery to pass into the C4 clutch, and no flow of power is possible through the power shift transmission with only one clutch engaged. With the clutch pedal depressed and the clutch spool pulled out, the pressurized oil available at the supply gallery restricting orifice passes through the orifice and is open to reservoir through the return gallery at the center of the clutch spool bore. As the clutch pedal is released, the clutch spool is stroked to the right and closes both returns to reservoir. The steering return oil is now pressurized, causing the reverse lockout spool to be actuated, shutting off the C4 pilot actuator circuit and opening the C1 and C2 pilot actuator circuits. The C1 clutch is engaged by oil supplied through the operated pilot valve. Although the C2 pilot is operated, the C2 clutch does not engage immediately because of the limited flow and pressure available. Oil passing through the supply circuit restrictor is directed into the gallery that supplies the C2 clutch. The restrictor limits the flow volume, and the modulator ball and spring in the end of the clutch spool limits the pressure in the C2 supply gallery. As the spool is moved further to the right, the modulator spring tension increases, and a corresponding increase in C2 clutch pressure occurs. The control of flow and pressure in the C2 clutch supply circuit permits controlled or feathered engagement of the C2 clutch, offering a smooth start in vehicle travel. When the clutch pedal is fully released, the spool is positioned completely to the right, and the modulator valve no longer has a pressure regulating function on the oil being supplied to the C2 clutch. The oil flows in each power selection are now complete, except for the operation of the retard valves during the shift process. The C2 retard valve is responsible for retarding C2 clutch release in shifting up from low to second and in shifting down from high to second. The C3 retard valve has the same purpose in the shift down from second to low. An example of the retard valve purpose in the system can be given in the low to second shift cycle. In low, clutches C1 and C2 are engaged. The pressurized oil that actuated the C2 pilot was directed through the opened C2 retard check ball. When the selector lever is shifted to second, the C2 clutch must be released and the C3 clutch engaged. The pressurized oil that actuated the C2 pilot valve must be exhausted by the return spring force on the pilot. The pilot exhaust flow is restricted by the C2 retard needle valve, causing a delay in the return to closed position of the pilot. The purpose of this action is to retain the C2 clutch engagement until the C3 clutch is sufficiently engaged to pick up and carry the load. Excessive restriction of the retard needle valve will cause the releasing clutch to be retained too long and will develop excessive engine load during the shift. Insufficient restriction at the retard needle valve will cause a momentary loss of power to the wheels because of releasing the disengaging clutch too rapidly. It has been our intent to briefly explain how the RPS-34 transmission works in this program. Your future problem diagnosis of the power shift transmission system will be dependent on your understanding of the system. Review this material often for the best results. 2 other programs on the RPS-34 transmission are also available for in-shop training purposes: Hydraulic System Diagnosis and Servicing the Power Shift Transmission. Know your equipment line and its service requirements. The future of your service shop depends on it.